starting from here, maybe one or two, not many, we will talk about overall architecture of IoT ecosystem. Okay, it's not limited to only the IoT device. It includes all the network layer and all the applications running at different locations. It includes all the devices, cloud, internet, everything together. Now, I will introduce you to the broad architecture of unit IoT, that means one single IoT end device, and ubiquitous IoT, that means which is pervasive all around and the whole ecosystem of IoT devices. Now, what is ubiquitous? I am sure you might have heard about it. It's constantly encountered, which you see very common and widespread in the industry now. And other names for this related to this computing is pervasive computing or ubiquitous computing. So after talking about this is based on one paper which I found that it is very useful and very good to read. Gives you a good overview of how these two ways of modeling an IoT environment is well written there. I will give you the reference to that and I will share the paper also. Then we will look into a reference architecture given in the reference book number 6. So there is no standard like a OSI layer in IoT world. It is getting into that area. So we will see one reference architecture which need not be the one which is being followed by whatever literature you come across. They may not be following this, but more or less you can map anything that you come across to one of these layers. Now, why do we need an architecture for IoT? Now, before I go into this, let me give you one small introduction. I am sure you must have heard about POSIX. It's called POSIX, Portable Operating System Interface. Now, what is it? This is a API definition. Okay, POSIX does not implement anything. It is a definition of an API. Now, what is that API? You know that any operating system, if you want to use, there are so many functionalities that OS provides. One is process management, memory management, then control and communication, like inter-process communication. Control means semaphore, mutex, those kind of things. And then communication means IPC, inter-process communication, like mailbox. So many other things, right? Shared memory. So different OS, suppose I take an example of Windows and then Linux, then maybe Mac. All of them have their own APIs, system calls, we call them as system calls, and they have some parameters, type of parameters to be passed. If you want to create a task, you may have to do something in Windows, which will be different from what you do in Linux, and of course it will be different on Mac. If you are writing a systems program which needs these APIs, Windows APIs, you need to use different APIs based on where you write your software. Now what happens? I want to write one system software. System software means which interacts with the OS directly. Okay, directly in the sense it is using the OS APIs. Okay, and it interacts with that for accessing the hardware or even process related things. It can create process, all those things. Now, if I write a software for Windows, it will not run on a Linux system because the Windows APIs are different from Linux APIs and their parameters are different, orders are different, structure what you need to pass and what the function returns, they are different. So you may have to rewrite the whole thing when you are porting your application to different OSs. So to avoid this, what they have done is they defined an API which is called POSIX API, and this in turn actually provides you some fixed APIs. Suppose if you want to create a task, it gives you one API. What are the parameters, what type of parameters, and what is the return value. And if you are running it on, suppose underneath this Windows is running, you don't need to worry about that when your application. In your application, you only use the POSIX API. Then there will be a library which will be provided as a POSIX library, which is also implemented by the parent OS. Suppose I am owner of Microsoft is the owner of Windows OS. It will provide you the POSIX library, which if you build it with your application, it will take care of mapping all your POSIX APIs to Windows API. And then internally, it will call its own Windows library. Similarly, if you are doing it on Linux, they have a POSIX library also. So your application also can run on this. Only thing is you have to link it with the POSIX library of Linux to run it on Linux. It not only this, even RTOS, different OS, Windows, POSIX, or WinRiver operating system, or even QNX. There are so many real-time OSs. They all, even free RTOS, they also have a POSIX interface compliance. It's called POSIX compliance. So any application you write using the POSIX API, it can be ported onto any OS, and of course, then it can be ported onto any hardware, because OS would have been already ported, and hardware is there, CPU, new CPU, OS has already been ported, and you have a library which is POSIX library, which is also provided by the OS vendor. Then your application is independent of, or it is not dependent on, what is happening below. Right now your application is running on a particular hardware, particular OS now, and new version has come for this, they would have built the POSIX API library also. Now your application runs on this also without any problem. So that is the beauty of having layered architecture, or having such a interfaces like this. So IoT also needs such a thing, basically because it involves many technologies, including architecture, sensor identification, sensors or identification units, coding, what kind of data which is being sent by the encoder or the sensors, and different kinds of transmission. Right? Today we have Wi-Fi, tomorrow we have Wi-Fi 6, then 4G is there, now 5G will come, and different kinds of data processing and networks discovery. Now you have to discover different applications or services which are available. So IoT is a mix of many things, and if OS needs an API like POSIX, IoT is also very much needs. This also needs a good architecture. Okay, so IoT development depends not only on the progress or standardization of technologies, but also on the improvement of our social perception. See, right now we are all tuned to a police person standing in the signal to stop you and then give you a ticket. But once IoT comes into play and Bangalore becomes smart city, or Lucknow also is becoming smart city, then you won't even know that you have been tracked. Your vehicle license number is tracked, and you will be getting an email saying that no, you are violated in particular time, particular location with a photograph or a video. So you need to be aware of these things when the IoT technology is coming into play and it becomes pervasive in the environment. So that also we need to take care. Okay, and in the development also we need to take care of that. And in the future IoT era, where the way we live and the way we interact with the different nodes and networks and the facilities that are there in our surroundings, in the city or in the hospital, there are so many other issues like privacy issues, security issues that need to be taken care of. So a standard, reliable, robustness of IoT is important. And if you need to develop some application or even a middleware or any of the components which are part of IoT, we need to be aware of this layer and the importance of why you need to have a layer. Okay, layered architecture. And one more thing, as you understood from OSI layer, the layered architecture helps you in isolating and grouping the responsibilities in each layer. So you need not to worry about the proper, the services offered by the lower layer for the upper layer. So similar to OSI, what you have learned in networking, network IoT also needs such an architecture or standardization of that. So the reference IoT architecture is not only a key requirement, it also a foundation for future IoT development. As well as one more thing, someone mentioned also that IoT devices that today we planned or today we install, their lifetime is 10 years or more. So when the lifetime is more, you need to take care of these things, because the technology what you see today is not going to be there tomorrow or few years down the line. But the IoT devices need to be alive and they should be relevant even after a few years. So this kind of architecture will make sure that what we want happens finally. Now this is the paper I was talking about. It was published in April 2011. I will share it with you. The link also gives you directly to the PDF of this paper. It talks about two types of IoT. One is unit IoT. Unit IoT is one particular end device. Okay, an edge device. Ubiquitous IoT means it involves everything. All the software, networking, or multiple IoTs involved. Okay, that is called ubiquitous IoT. Now, what is the architecture for this, and what is the architecture that we go for capturing this ubiquitous IoT? Now, at the individual level, we treat it as a man-like nervous system. Okay, as an individual IoT edge device, it may have different sensors. Okay, and it will have a connectivity to the network also. So this connectivity talks about nervous connection. Okay, nerve endings or nervous connection, and somewhere in the cloud we have the central cloud. Okay, in the cloud we have a central device which is called management and centralized data center. Okay, there is something which is controlling all the IoT devices. I am talking about one particular IoT device. Okay, device. It has multiple sensors similar to our human body. So how do we model this? Modeling of this is done similar to a man-like nervous system, which you will connect it with all the sensors are connected internally using an SoC or system on a chip. That is, or you can even enhance it a little bit, modify it, and put more controls inside the chip. And if the IoT device is having a processor which is powerful enough, then you can have multiple complex software running here, which will take care of different decisions also, which is called edge computing. So we may have a modified model of MLM. Okay, so this is one particular individual IoT device. Now what if you have ubiquitous IoT? That means everything connected, intelligently controlled, and anywhere covered. Means it is all over the place, and they are all talking to each other, and they have a centralized control or a distributed control. Okay, there is no centralized control now. It's a distributed control. That is called social organization framework. Okay, these individual things are group of IoT devices. Now let me explain a little bit to give you a context of what I am saying here. Maybe if you read the paper, you will have a better idea. When you group different IoTs at a city level or at a home level, okay, then it becomes either called a local IoT. Okay, local IoT is all the IoT devices in your home could be called as a local IoT. So this ubiquitous IoT model is suitable for multiple unit IoT devices connected with each other and communicating with each other. It could be in the industrial environment, or it could be at a national boundaries, or it could be at a global level also, where multiple devices installed on different countries, they all interact with each other. Now, if you have such a wide ubiquitous IoT devices, then what you need is the central control data center. They will be distributed as well, and they are directly connected to each other, each of those groups, as well as they are interconnected also, because they are supposed to work as a single model, which is called a social organization framework. Okay, kind of a Facebook organization could be thought of different people interacting with each other. So it's like that. Okay, different IoT devices from different countries or from industries or different branches or even homes, they all controlled by multiple data centers or cloud platform, which is falling under this SOF model. Okay, this is a very high level model of such IoT devices. Now, I am going to talk about little bit more details about what you see or what are the multiple layers you will see in an IoT architecture. So, IoT should have the capability to connect and transfer data among billions of or trillions of devices. Okay, they have to have the capability. They need to work seamlessly, and it is critical to have a layered architecture if they need to work seamlessly. That means when I say seamlessly, some device may come into the network, they will go out of the network, or I may replace one with the latest version of the device, or I may buy from different vendor and then put it in the IoT network. All that should work without any problem. I cannot say that if I buy from Samsung only things will work, or from LG. I may have any IoT device from any vendor. It may be running any different OS or a different CPU may be running there, but still it should all work together. Now, earlier days, the layers of IoT was only simple 3 layers. Perception layer, which is nothing but the IoT device, which is perceiving the world environment where sensors are connected here. And then network layer, as I mentioned, IoT device cannot exist alone. They need to be having a communication methodology, some way of communicating with the rest of the device. So network layer is a must. And then application layer. Of course, what you want to do with that set of devices, that is what is decided by the application. So this is the very high level initial layers defined. And then it was as the research went into each of the layers, they started detailing out, saying the transport layer, processing layer, and application layer. Okay, don't worry about it. I will talk about each layers now. Then I am renaming this little bit, which is being available in the reference 6 book on chapter 3. Objects, object abstraction layer, service management layer, application layer, and business layer. Okay, that's all. Only 5 of them, not like YSY 7 layers. We will go into the details of each of them today. The architecture should be highly scalable. Okay, the IoT architecture should be highly scalable, flexible to accommodate the wide gamut of components and technologies that are part of the IoT ecosystem. This is very, very important line. I hope you understand why we need an architecture and what is the requirement that architecture should support. Though there is no standard architecture for the IoT ecosystem, a generic 5-layered reference layer architecture is given below. Okay, it's not standard. You may see something different, so don't think that this is the only way to define the architecture of IoT. When I say IoT, don't think that it is only one device I am talking about. It is a whole ecosystem of IoT devices. So let us go into the reference architecture. The object layer is also called devices layer or perception layer. There are different names for it. It actually comprises the physical devices that are used to collect and process information. When I say it is not only collecting the information, collect means it is sensors, but it is also processing the information, means there is some little bit of maybe removing the noise or fine tuning the number of sensor data that you get may be compressed into a small form so that it can be sent across the network, or even processing it and taking action then and there. That is called edge computing. So that is what is the role of object layer. Not only sensors, it also has processing responsibility also based on how complex the object layer is or how complex the IoT edge device is. Okay. Now it includes MEMS. I'm sure you might have heard about it, micro electromechanical systems, which has got micro sensors, micro actuators. That means you also can disturb the environment. Microelectronics, there is electronic circuits inside, and microstructures. That means all these things are very nanotechnology is used here to build such devices. It could be like pump, or it could be like a valve, or it could be something which is going through our bloodstream. So this nanotechnology is also a perception layer, falls under this, and it could be connected to the network of devices in a body. So it's a IoT device. Okay, MEMS sensors with all this intelligence built into it. There will be some software running also. Okay, or it could be like hardware control. Now sensors could be optical sensor, light sensor, or gesture sensor, or proximity sensors. There are so many sensors that could have, and they should have a plug and play mechanism. That means I can just bring any third party vendor sensors and plug it into an IoT system and it should work. And the responsibility is to, they collect the data at this layer, and their responsibility is also to pump it into the object abstraction layer. So how often they do, whether they sleep and then wake up and without this consuming more power, they do it. They are all part of the object network layer. And also security is important. Okay, secure transfer of the data is also important. I hope you understand what is object layer. Now object abstraction layer, which is a layer transfers data that are collected from here to the service management. It is very obvious. And it specialized processes for handling even cloud computing and data management. Okay, this part may also have some cloud computing and data management responsibilities, because if it needs to be connected to a particular AWS or some cloud, then those client modules of those cloud devices or cloud architecture need to be running here. So that's why I'm saying that there are some components in the object abstraction layer which are involved or responsible for connecting to the cloud, because beyond this layer it is all network. Okay, the device ends here. The IoT device almost ends here, and it takes off from here into the network and the cloud. So you can see the transition happening there. So data transmission can happen using any of the following technologies. Now I'm not put it in proper order. So I'm sure all of you are aware of most of these things, which I already covered in the last 3 lectures or 4 lectures. So these are all the transmission technologies which are being used for transferring the information coming from here to the service management. Now you can see that this particular layer is, some of this is also part of the IoT device, and some of it may be part of the network. You can imagine a Wi-Fi router is, if you suppose you are using a Wi-Fi for communicating, there is a Wi-Fi device here on the IoT communicating with the Wi-Fi router. So router comes here in this layer, but in this itself, some part is in the object side and some are in the network side. So you can divide this abstraction layer into two, one like a MAC layer or data link layer, and then physical layer. Similar to that, you can divide it into two half. One is on the IoT device, the other half is on the network side. Okay, so I'm sure you are able to relate with all the technology that you have learned with this layer. Okay, that's my intent of defining all those things initially and then exposing you to this different architecture so that you can connect with what you are seeing. Okay, now you understood that now data is collected, maybe processed, and then sent across over the network. Now handling the network portion, carrying the data, or even collecting information from different IoT devices is the responsibility of the service management layer, and it's also called IoT middleware. Okay, you may hear this very often. IoT middleware is nothing but the when I say layer, that is a module or software or a hardware which is taking care of this responsibility in the IoT ecosystem. So it pairs specific services to its requester. Okay, request is coming from the top, and then pairing it with a particular device is done by this layer. It provides flexibility to the IoT programmers. IoT programmer can be anywhere. Okay, when you say IoT programmer, based on where you are landing into, you may be writing some software here, or maybe in the application layer, or even business layer. So any IoT programmer they need to have ability to work with heterogeneous objects irrespective of what platform they come from, what manufacturer it comes from. So one popular middleware of IoT is this company. Okay, maybe you can read about it. What they provide is they provide the middleware, and they also give you software that needs to run on specific hardware. So they already supported some set of CPUs. Okay, and then they also have tie up with different cloud vendors based on your business company that you work for. They might have tied up with one of them, and then this you can buy the middleware, and then they will also provide you all the software that needs to go into this hardware, and then you can fine tune it to your application requirement. If you are doing a smart city project, you can buy from here and then configure it for smart city, or if it is a health, you can do it for health. So any application vertical that you do, you can buy this middleware and achieve it, because it has got a wide spectrum of cloud vendors they have tied up with, and they provide you all the basic framework and software, so you don't need to write everything. And similarly, you can buy the standard hardware, which already they have the software running on this MCUs microcontroller. So it's only application logic you have to put it, and then you can easily go to market by paying some money for them, of course. So this is one good example of IoT middleware. Now I am giving you more details about this. So they have a like Arduino IDE. They have an IDE so that you can develop some software based on what hardware you have purchased, and you can upload the software into this board. In this kind of scenario, you cannot develop software on the embedded system. Okay, you cannot write a software like Raspberry Pi. Raspberry Pi, you can develop software on top of it. You can run the code block or even all the compiler, everything you can run on a Raspberry Pi and work. But a small microcontroller from SDM or ARM Cortex M3, you cannot develop because it is not powerful enough to run a compiler there. So you do always a development platform and then upload the software into the embedded hardware. So that's how we develop embedded software, this is called target hardware, and this is the target hardware. This is the development system host. This is called host. This is called target, and you develop using the IDE and upload the software there. Then it runs with the rest of the system. Then this host is not coming into the play when your IoT system is running, but it's only coming into life whenever you develop some software and upload it onto your IoT devices. So the hardware CPU can come from any of the vendors, and you have a backend any cloud vendors. Then this particular middleware helps you in doing it. So you can imagine the session management comes somewhere here, and this is the device layer object, and the connection is object abstraction layer. So I hope you can understand the whole gamut of the layers that I explained you. So this is about Zerinth. Okay. Now let me see if there are any questions around before I go into the next layer. I hope you guys are following. Fine, no problem. So let me, how much time I have? Okay, 30 minutes. Okay, guys. So let us, I hope so far so clear. Now application layer. Now what happens is you have collected all the information. Now what to do with the information? So all the logic, application specific logic comes in this layer. It could be for different services. When I say services, you may be, suppose if you are building a smart city solution for a traffic police, then the services could be tracking the cars which are violating the rules, jumping the signal, collecting the information about the license plate, and then getting all the database related information about this, access the RTO's database, and then collecting information about the car owner, and then generating the email with a notification saying that this is where you did a violation, and then capturing the information for later on for legal purposes, and storing it in somewhere, maintaining it some in database or in the cloud, and then communicating with the police as well as with the violators. So the whole thing. And suppose if you are doing a security surveillance cameras. If you are installed it is coming up in camera, in Bangalore, wherein they will be doing a face recognition to identify any women in the road are showing some kind of apprehension in their face. Then that means the person is in danger. Then it will generate a emergency signal to the nearby police. Then they can come to the place where the things happen. So even any violence happening inside a city, they can easily capture and give it. So that kind of business logic, or that they fall under these two categories, business application layer. But you may install a camera in a row on a road for different purposes. It could be for surveillance purpose, or it could be for a traffic control purpose, or it could be for autonomous cars, anything. So different application may need different kind of logic which needs to be built into this area. So different use cases, that's what is called use cases for different customers. Customers are police or automobiles or autonomous car vendors. It could be anything. So the use case depends on the choice of smart services. What service you want to provide using your IoT device. So there are different verticals: smart cities, smart energy, where you want to collect information about different. Right now all the meters are all smart meters, and even the basic in Bangalore, electric Bescom is giving you an option. You can install a solar panel at home, and you can generate electricity and then feed it to the grid. Okay, you can start supplying excess energy that you generate, current you generate. You can feed it to the grid so that Bescom can save money from generating power or borrowing money from electricity from some other state. So they will give you some concession on how much power they draw from you, and they will give you some money or concession on your bills. So this kind of smart grid or smart energy needs IoT devices and communication between different devices and the Bescom control. So a lot of things involved. So it could be possible for that. Or healthcare, you can even do a remote monitoring of health, and even surgery could be performed remotely. Smart homes, there are home appliances can be controlled, power can be switched off when the person is not there, or even for a safety purpose, you can, even when nobody is there at home, you can run an application where it will switch on the lights in your home at a different point in time, giving an impression to the outside thief waiting to barge into your house, giving an impression that there is somebody inside the house. So you can even simulate condition of someone moving around in the house by switching on or off the lights. So those kind of scenarios you can build into the home, and that kind of intelligence can be built into the layers, application layer or a business layer. Business layer is more of profit and other things, but application layer is in terms of providing services to the customer. Okay, so do not mix both. Whatever use cases I'm giving, they all fall under application scenario. Smart living in terms of comfort, providing comfort to the person, setting the temperature at home, or air conditioner, or TV volume, or lighting in the house. There are so many things. Transportation, you can have I hear that Singapore has a autonomous bus in the city, so you can provide such a facility. Industry, you can have autonomous control of things going into the different stages of the manufacturing. So smart industry can be built. So there are different layers, different applications there for you to implement using IoT devices. I hope you get some rough idea of what application layer is all about and what all the responsibilities this layer is supposed to handle. They are supposed to handle different use case scenarios for different IoT verticals. Okay, that's a single line summary. Now, what is business layer? Now, nobody wants to install IoT devices or provide services without having a business profit. Okay, business advantages. So this is the overall management of IoT devices. It's not only profit, but it also talks about how efficient your services are. If there is a failure, how would you recover from the failure? How do you manage many devices in the network and which is failing and how to replace them, what is the issue, how to resolve those failing devices, or updating the new software on all the devices. So there's a whole lot of things to even maintain IoT service provided to a particular customer or a particular area in an industry or in a home or a city. So there is a lot of data analytics come here. Design, analyze, implement, and evaluate those IoT systems. So you need to continuously evaluate whether the IoT system is behaving as per the requirement or not. If there is you are committed to the customer that you will provide some kind of a service. Okay, is the device or your system providing that, meeting the requirement or not? If it is not, you may have to charge less to the customer, as well as you have to recover from the loss, recover from the failure, and make sure that you meet the requirement. So these kind of things fall under this business category, business layer. Okay, maintaining the services which has been promised to the customer that the application layer would provide. Okay, application layer is for providing the services. Business layer is a manager sitting on the top, making sure that everything underneath is working fine. So it has got a capability to do big data analytics, support decision making. Okay, all this, very high level overview. Mostly data analytics come into this area. Okay, most of embedded things come here, networking comes here, and little bit of cloud computing comes in this layer, or application development or web services or container, Java, all those things comes in the application layer. And business layer is more of cloud computing as well. Any of the decision making, data analytics, more of data analytics comes here in the business layer. Okay, because you need to continuously monitor and charge the customer, as well as maintain the quality of service, quality of experience that you are committed to the customer. So that needs big data analytics portion in the business layer. So this layer uses the data that are received from the network layer to build various components such as business models, graphs, and flowcharts. Suppose some user wants to know how many times my IoT devices have failed, or how many times the services were not up to the mark, and the network speed was below the normal committed data rate. So those things you need to provide when the user wants it. At the same time, you have to maintain it locally so that you can recover from those losses and then meet the requirement of the customers. So I hope you understand what is the purpose of business layer and what it is supposed to do. So it also performs comparison of obtained versus expected. Okay, that's what I mentioned. What is actually happening compared to what was committed or expected output. So which is very related to quality of service or quality of experience. It also employs many technologies, databases. Of course, I missed out database. Yeah, database, cloud computing, big data analytics, all that come under this layer. It manages the whole IoT system, including applications, business, profit models, and user privacy. Okay, user privacy is very important. If there is a violation or if there is a leakage of data, the business is going to have a severe problem. So that is very important. Security, privacy is the most important thing in the IoT environment, where because there is a data collected at different point and it is all coming through the network. So there is a possibility of the data leakage and middleman attack. So man in the middle attack. So you need to handle this very carefully. So that's why encryption is provided. I mentioned something about AES 128 somewhere. If you remember, AES 128 encryption at the IoT device level, it is for this, which is to be provided by the business layer. You need to take care at the device layer to handle it. Okay, you cannot expect it to happen suddenly. It needs to be handled at the source where that data is generated. Okay, I hope you understand the connectivity between these layers and how they interact with each other. That's what I wanted to have it today. Let me see if there are any questions. I completed intentionally a little early for some reason. Our famous printf, I don't know it is famous or notorious. I am sure all of you are a bit disturbed with this assignment. Okay, I felt it, but I won't say it was people were a little scared in IEEE also. But I think it's only earlier fear. I'm sure you can handle it, provided you put in some effort. So what I gave you a code yesterday, okay? Actually, that implements only integers. If you follow only forward, give only integers, what happens? But what you are supposed to implement is, what if I give you float, double, and whatever, char, or even character star? How do I handle it? I know it's not easy. Okay, let me tell you. But if you spend some time, effort, you will be able to do. Now, I will tell you some suggestions. Okay, if you try writing the code and then try to debug it, one thing I expect you to do is, do not change the IDE. Once you freeze on one IDE, do it. I suggest code block is good unless you have something which is better than code block. I am fine, but otherwise, please use such a decent IDE which helps you a lot of debugging abilities. Okay, that is one thing. Second, you are free to use printf, okay, to debug purposes. Okay, please do that. Always use more printf to know what is happening, because sometimes you will be making mistakes and spending a lot of time without knowing what is the value that you are getting on each level. So put liberally some printfs, make sure that you are using printf properly, and then see the values that you are getting, try to understand what is happening. Third, I forgot what I wanted to say. Okay, yeah, debug facilities. Okay, you can put breakpoints, okay, and then watch the variables using code block. Okay, if you want, I can run through once how to do it. Okay, there are so many facilities available. You can put a breakpoint on in a software and stop and then analyze it. I don't want you to go through the register level because that is not required. Though I explained you all that with the register level, to write this software, you don't need to go to the register level at all. What you need to do is, do not use anything other than the library, C library routines, like size of, okay, use size of, and then if you are in doubt, do not add something, some pointer type, okay, do not increment or do something without changing into void star, because you will be thinking that you are incrementing by only 4 bytes, but it will do much more. So those nitty-gritty, you need to take care. Okay, and then liberally use brackets if you are in doubt, so that there are no mistakes creeping in because of just careless error. And one more most important thing, please choose proper variable names. Okay, it will actually help you. I'm not asking you to write a long name like my name, Chandramoulishwaran Sankaran, but write a meaningful name, so that by looking at the name, you will know what is the type of the variable, what it is representing, so that while debugging, you will not make mistakes and you will write a proper code. And then please follow coding guidelines, because it will help you in writing properly. And then 6, though I told you that it should run on Windows, Linux, ARM, Intel, I am not going to check it on those all the processes and then make sure that they run on it, or I don't expect you to do it. Though it will be a good exercise to do that, even though you don't test it on different platform, it is a good exercise to do. Now, what do you need to do? One good example is when you are taking care of stack growing downwards, do not leave out the else condition, stack growing upward. Write the code for it. Okay, though you know that the current architecture what you are running on Intel is only stack is going down, do not stop implementing for the else portion of it. The reason I am telling you is, you will know what to do when you start implementing it. That will help you when you go into companies and then start implementing such software, and you will be different from the rest of the gang, and you are going to make a difference when you do such work when you go into the company. And not only there, even in the interviews, if this kind of awareness is there, people will really grab you because they want such people who are knowledgeable during the college days itself. So you need to do it. Don't get scared. Then, last point, if you are stuck, okay, you don't make a progress for maybe 2 hours, you are breaking your head, but you are stuck, you don't know what is happening. Do not hesitate to share the code, okay, with me. You can share the code with me, but don't dump the code which is not even compiling. Don't give me a code which is not even not tested by you. Don't give me a code without even trying what is happening. I am not your debugger, but I can help you because it may be a small mistake which will take hours for you to find, which I can do it in minutes. So I don't mind helping you guys, but do not give it to me without you giving it a try. And even if you are giving it to me, today Sandeep was interacting a lot with me. He was giving me a code, okay, properly written, and then he also gave me the output what he is getting, so that even I don't have to run the code to give him the help. So he gave me the output, he gave me the code, in a proper, with all indentation and other, screenshot or whatever, which helped me really to easily look into the code and then give him suggestions what is happening. So I can do it. You help me, help you. I am willing to help you in case you are getting into trouble. I know it will be, difficult because you are first time you are doing, most of you. So please ask me questions. What is the issue? And please discuss among yourself. I am not stopping you from discussing. Please don't think that I don't want you to discuss at all. Please discuss how to solve this particular problem. Discuss, get a solution, understand, and write your own code. Write your own code. Help each other, but do not just copy code from somebody.